Hello, my name is Rachon. I'm section leader of Brewing Microbiology Research team here at Camden BRI. And today I would like to talk to you about research that we're doing looking into survival of pathogens in non-alcoholic beers. We started doing this research a few years ago because popularity of non-alcoholic beers is still increasing, and it looks like those beverages will stay with us for a long time. But also we started doing this because a number of publication looking in this problem is very limited. We've got few good publications looking into this, but not many. This publication suggests that pathogens can grow in non-alcoholic beers very rapidly, but they don't explore ways how we can suppress those growths, how we can control a growth of pathogenic microorganisms in non-alcoholic product. And this is where we were really interested. We were really interested to finding the ways how we can control it by using the typical parameters of the beers, looking into the pH, bitterness of carbonation. So we started doing this project by purchasing 50 non-alcoholic beers from the UK market. Those were not only British beers, those were beers from all over the world. We wanted to see if we can find any pathogens in those samples. So we tested them for the presence of E. coli, Salmonella, Bacillus cereus, Clostridium. We tested them for Enterobacteriaceae. We tested them for typical aerobic beer spoilage bacteria, anaerobic bacteria. We also tested them for bitterness, pH, and alcohol level. The results from this testing show that we haven't found any pathogens, typical pathogens, E. coli, Salmonella, Clostridium, or Bacillus cereus, but we found some opportunistic pathogenic microorganisms, which kind of opened our eyes on this, because we were focusing on the typical pathogens, but we found something else which worth exploring. We also find out that 8 beers out of 50 beers tested contain slightly more alcohol than guidance level of 0.5%. And I think that, of course, this was a few years ago. I think if we would do this test again now, we probably would see that I don't think we would find any beers that would have higher alcohol level, but well, we may have to try to do this again. We also did challenge testing, trying to investigate impact of those key parameters into survival of pathogens. So we select one beer. This beer was low bitterness, so we modified this beer, adding isolated hop extract to 25 IBU and 50 IBU. We also modified this beer with adjusting this beer to different pH levels, and also we did test in fully closed, fully carbonated condition, like bottles and cans which were closed, and decarbonated condition. And what we find out that the bitterness really didn't impact growth of pathogenic microorganisms such as E. coli and Salmonella, which we were kind of expected, because it's well known that hop extract impact only gram-positive bacteria, but we also thought that they would impact growth of and survival of gram-positive bacteria which we use, Bacillus cereus and Clostridium botulinum, but nevertheless bitterness didn't impact those microorganisms too. And we found that most impactful parameters was pH. We tested our tested condition was pH 3.8, 4.2 and 4.6, but also we shown that pathogens can grow only in beer when this beer is decarbonated, which was something that we didn't really expect, because those microorganisms that we use are enteric microorganisms, E. coli and Salmonella, and those microorganisms can grow in both aerobic and anaerobic conditions. Nevertheless, we've shown that when beer is fully carbonated, growth of those microorganisms is suppressed mainly by pH, but when the beers are decarbonated, those pathogenic microorganisms can grow, but again they would grow in higher pH. This, of course, lead to us to do more research. So at the moment we conducting research trying to find out what those carbonation levels are. We want to know what level of carbonation is really critical to suppress the growth of pathogenic microorganisms. So if you will be interested in finding out this, please tune in back or get in touch with us. We should be finishing this second part of the study by the end of this year. Thank you very much.